All right, so I am able to make this oximeter work, and so if you look at the circuit, that's IR emitter and receiver pair. So this clear one is the emitter, and the black one is the receiver. Okay, and I have two stages of op amps. Actually, they are instrumentation amplifiers. So every stage, I'm using a 1K resistor as a gain resistor. So in theory, I'm getting something around 50 times gain, voltage gain every stage. So two stages will give me 2,500 times gain, all right? And the last stage is a comparator. It's a very simple 741 op amp, and it's not amplifying anything. It's just trying to give you a digital signal to turn on, turn off the LED light. Because when you are testing your the blood flush in your fingertip, you want to see the heartbeat. You want to visualize your heartbeat by looking at the blinking LED. So which will be more fun. All right. So the input comes from the receiver, and then the next one will be the high pass filter, and then the instrumentation amplifier, and then the low pass filter, and then another instrumentation amplifier, and then the comparator. Okay, it's pretty simple. I can see that before I have any signal being injected into the instrumentation amplifier, you can see the DC offside voltage is something around 2.5 volts. So this is what I designed because I'm powering up this instrumentation amplifier with the 0 to 5 volts. And you can see I didn't have put my fingertip on the light sensor, but you can still see the signals changing. It is because it's pretty sensitive sensor. So whenever I'm moving around, it's actually changing the reflection being received by the receiver. Okay, you can see that so this is reflection. This is not heartbeat signal. All right. So now I just keep myself far away from the sensor. And you can see it's going to be stabilized at 2.5 volts. A little bit noise. Okay, all these little pulses are noise, but your heartbeat signal will be a little bit larger than that, so you are able to see that actually. So now let me put my finger onto the IR sensor, and you should be able to see the pulses from the oscilloscope. You need to wait for a few seconds until it is stabilized. All right, so the signal comes in, but it's a little bit smaller than what I expect. Not sure if it will trigger the comparator to blink the LED. All right, it actually triggers the LED. So you can see it's blinking. The voltage is too small. Let me sit down here and, you have to push pretty hard because this is not ideal. This is ideally you should have one on the top, one on the bottom. But this one, it's used for the smart car, but not for this purpose. So I'm gonna trying to hide all these area over here and see if I'm getting a stabilized signal. So the signal is fine. It's not the best I've ever seen, but I think it should be able to blink this LED, but it's not. Oh, it is. Right. Great. You have to wait for a few seconds. Okay, so that's my heartbeat. Believe it or not. So that works. And now the signal is more stable right now. I think because I'm pushing pretty hard right now, and so my skin on my fingertip is getting thinner or whatever. or it's giving a little bit pressure to the finger, so the vessel is trying to pump more blood to the fingertip, start getting a stronger signal. All right, so if you look at the oscilloscope, it's pretty stable. Okay, so that works. So now, what I'm gonna do is I will. I don't want to move. If you move, you see the signal looks weird. All right, so I'm gonna stop the oscilloscope and use a cursor to measure the heartbeat rate. Oh, stop. Okay, and then I'm gonna move the cursor one to here, another one to here, and you can read. The delta T is 635 milliseconds. So it's a little bit, excuse me, it's a little bit faster than 1 hertz. Okay, but that doesn't matter because, you know, the filter is going to work for this purpose. All right, hope you can get this work on your side.